how we roll, man. Some rock, some win, some roll, man. Some rock, some win, some roll, man. Some rock, some win, some roll, man. Some rock, some win,
Sorry, I got the rhythm wrong. Hello, everybody. Zig Show time number 40. Yeah. Now, I was looking at the number 40. It's not that high, but it's still surprisingly high. Usually, I don't do things for that long. In any case, let me tell you very briefly about like one interesting piece of news, and then we can get into the episode right away. So you might be interested in knowing that there's that Systems Distributed has been announced. And it's going to be in Amsterdam at the end of June, I believe. So, you know what? If anybody in chat can put a link to systemsdistributed.com, that would be appreciated. So, Andrew is going to be there. If you're interested, he's going to be speaking. I will also be there, and I will also give a talk. So, if you want to, if you happen to be nearby Amsterdam or Europe in general, consider showing up. Thank you, Blurry Cat. So, with that out of the way, let's get into the topic of today. So today the topic is a WebAssembly runtime called Orca, but WebAssembly runtime doesn't really even begin to describe it, I think. So today we have with us Martin Fouilleul, who is gonna tell us more about it. So let me bring Martin up on stage. Hello, Martin. How are you?
Hello, I'm doing fine. And you?
I'm doing fine as well. Thank you. Man, it's so nice to see the light in your room. I had to turn down my shades because otherwise everybody here would see that I have like a ton of sunlight coming in from nowhere, which makes no sense with the green screen. But yeah, summer is coming. That's nice.
Yeah.
Nice. So, I don't know. Maybe we should do some introductions. Sorry, I'm so bad usually with introductions. I'll say this, though. I met Martin, I think we first met at Handmade Seattle, I believe.
Yeah, I think 2022 or even before.
Might have been 2022. Yeah, I think 2022 is the first one that I attended. At the time, you hadn't started Orca yet, did you?
It had just started. It started as jam project basically, and then it got out of hands.
Nice.
So yeah.
Nice. Okay. Nice. Well, then I don't know. Is there anything else that you think might be interesting for the audience to know about you before we jump into the details of what is Orca?
Well, yeah. Well, we can talk about that. Well, a bit later if we talk about like the long-term projects about Orca, but we can like maybe dive right in and I will just give a bit of context. Like you said, Orca is a WebAssembly environment for making portable application. And now I'm kind of using the word environment instead of runtime because it gives a better hint about what it is. Mm-hmm. Because contrary to most other runtime, it not only runs a WebAssembly module, but it also gives you a set of predefined APIs to interact with the underlying system, including all that you need to make interactive application and graphical application. So you have graphics API, you have I/O, you have input. And when we get to adding them, you will have networking and audio and that kind of stuff, which are not generally in other WebAssembly runtimes, which are more geared towards command line utilities or, I don't know, backend services or stuff like that, where you have less batteries included to make applications. And you also have like an SDK that's compiled to WebAssembly and that's linked to the WebAssembly module, which is also not something you typically find in other runtimes. So it's more of an environment where you have all the tools you need to make portable application. And speaking about tools on the programmers end, we also want to provide all kind of development tools. So currently I'm working on WebAssembly Debugger, and I also want to have like a profiler in there, visual inspectors for UI and all that kind of tool that help you make applications. So it's really more of an environment and complete development and distribution and execution environment. And so that gives maybe a bit of a better idea of what it is. And we maybe we'll develop later about the long-term project, but just to give a taste of that, the idea behind Orca is that okay, we are using web browser in a kind of ubiquitous way to build applications and to make them run on users' machines.
Yeah, to distribute them.
Yeah, and it's like they have a couple benefits, but they are not really that good at running applications. We only use them because they have these couple benefits that compared to what operating systems do, or rather to what operating systems should do and don't. So you have sandboxing, you have the ease of installation. You could say you also have the ability to link to external stuff. And all those things are good, but that's not because browsers have them that they are good at them and that they are good at running applications. And in fact, they were not designed to in the first place. So the goal behind Orca, just to put it that way, is to tear down the web browser as a platform and to rebuild it from the ground up and have the opportunity to reinvent how we build and how we share and how we execute applications.
Nice.
So we maybe we'll expand on that later, but maybe we can give a more concrete view of what Orca is today, and just like show how you would code an Orca application if you're up for it.
Yeah, sounds good. Demo time then.
Yeah.
Let's go.
So yeah, of course, we'll start from scratch. So I'll go to the Orca GitHub repo and download the latest release.
And now we wait.
Yeah, and now we wait.
Wait, it's 7 megabytes.
Yeah, I think the screen sharing stuff is throttling the connection a little bit.
Oh, I see. In any case, it's going fine. Like your screen share is good.
Yeah. And then so I put it somewhere. So let's make a directory somewhere in my home directory and copy all that there. And I also need that to be in my path. So let's open my profile here. And let's put that in the path. Orca. Okay, let's source that. Okay, now I should be able to run like Orca version. Oh, why?
Typo in the path.
Typo in the path, maybe.
Yeah, happens every time.
So users users / Orca / path.
Wait, how many L's in your name? Isn't that supposed to be 2 L's?
Yeah, that's supposed to be 2 L's.
Oh.
Yeah, I knew I knew I would mess that up. So we'll pretend that. Okay. Oh, get out of the way.
So still not working. I think you haven't sourced it.
Yeah. Save. Yes, save, please.
There we go.
Yeah, and so since macOS is very annoying, you also have to do a little dance with...
Oh, if you want, I think I can show you the short version of it. I suspect you were about to type in the terminal, right?
Yeah.
Let me show you what the mouse game people can do. Tab back to your Orca file explorer. So the file explorer in Orca, yeah, whatever this thing is called, Finder. Right click on Orca and then do open. Now you can do open. Close this window. Now the executable is good. You didn't know about this.
Marvelous. Huh? Yeah. I would do also like with in the preference stuff, but you have to type your password and like
yeah, it's complicated.
Just shows the number of letters you have in your password to the whole stream audience. So I didn't want to do that. Okay, so we have Orca in our pass, and that's so well and good. So now let's see what we have here. Let's delete that. So that is my my basic project where I have an empty C file. You will have to excuse my C. We will soon have Zig bindings, so we may be able to do a Zig one on stream soon. That would be fun. Here we have just an icon, some font file, and we have a build script that I also prepared because I couldn't remember all the flag off the top of my head. But it's still pretty simple. So here we're using the Orca tool to get the path of the SDK. We're setting some flag that allows to compile a WebAssembly module and link it to our standard clib and our SDK. We are calling clang to compile main.c to a WebAssembly module, and then we are calling the Orca tool to bundle all of that plus our resources into an application.
Yeah.
So let's run that. And now we have an application here that we can open, and it doesn't do anything because the C file is empty. So let's start coding, and we'll start by including Orca H.
By the way, if you can increase the font size a bit, that would be appreciated.
Yeah, I think I can. Is that okay?
Yeah, that's nice. Thank you.
Nice. So here we will define the handlers, basically. So we will export function that the runtime can pick up and use when it wants to pass us events from the operating system. So we will have OC on init handlers that's called on initialization, and an OC on frame refresh that's called every frame. And we have to mark them as exported using this Orca export macro. Okay. And so we might want to draw something to the screen. And we have to create some resources for that. And to keep it simple, I just put everything on the global scope. So yeah, don't do that at home. Let's say we have canvas renderer that will be used to use our canvas API. we want to render to a surface, and we will need a canvas context to put rendering comments into. Okay, let's initialize that. So create a renderer, we create the surface. OC canvas surface create from the renderer, and then we create our canvas context. Okay, we can make our canvas context current like that. Don't worry, I will make a lot of typos. And we can start using that canvas now. So let's set a color, something like a cyan background, and we will clear the screen. And now I want to render my canvas using my renderer, and I want to render the canvas into the surface. And I want to present the surface. So let's build that, and canvas set context. What is canvas context? Yeah. This one is select. And this is renderer.
Wow, usually it takes me longer.
Yeah.
Nice.
Okay, so we have our cyan background. So now let's draw some more interesting stuff in there. So let's say we have some position here and like that, and some radius. And let's set another color. And draw a circle with that position and that radius. Let's see.
Nice.
Okay, nice. And then let's have some eyes on that face, because yes, this is face. And I don't know, something like 16. We will draw some ellipses. And we'll have, okay, position x minus radius over 2 plus minus rx. Something like that. For the y position, I want to have that minus iry. And set some black color.
Okay.
Yeah, that looks not really something like that, maybe. Anyway, let's try to draw the other one, which should be just symmetric. Okay.
Nice.
And then let's draw a smile, and we'll use Bezier curve for that. So let's move our virtual pen to some position here, right behind the eyes. And something like plus y plus some amount. I'm trying to get that all relative to radius so that we can change the radius later. And so then we will draw a curve. So that one should be a little bit closer to the center. And a little bit down. Okay, the other one is symmetric in X and has the same Y. Radius. And the last point, we would want to have the symmetric from the starting point. So that would be plus 0.5 times radius. And plus y plus 0.4 times radius. Okay, we'll set some width. And we'll stroke that curve. So hopefully, if I didn't mess up my Bezier curve, it's kind of a smile. Okay, so let's make it move. I just had some velocity. Let's do something like that. And right before that, I will have an acceleration that will be just like a constant weight. And let's integrate the velocity by doing an addition. So we are adding the velocity to 1/60 times acceleration. And let's integrate the position with the velocity. And we should have something that's smooth and that falls over the screen. So let's make it bounce on the edges. So if I have my position that's less than radius, I will reset it to radius. And I'll just flip the x velocity. Likewise, if my position is so if position plus radius is more than my size, so let's get the size of our screen here. Okay, so I set size x minus radius. Okay, and then for the y, that should be just replacing x's with y's. Let's see if that works.
Nice.
So now we have like a bouncing smiley face. What I can show is, okay, maybe I want to give it a little kick sometime and just push it up when I press space, for example. So I will have another handler which will be activated on key down. I will have a scan code here and key code here. So let's say when the key equal OC key space, we'll just set the velocity to minus 280 or something. Okay, so here when I'm pressing space, I'm kicking the thing up.
Yeah, we can see that sometimes it like bounces up without touching the bottom.
Yeah. Okay, so that's kind of the basic for going and responding to input, and then I can show you some UI because we also have some UI system. So let's say so for the UI we'll need a font. So let's have a font here and initialize it here. And so by default, you have access to the private, like a private data directory of the application. When I'm building the app here, I'm passing this resource dir stuff. So it's just like copying all, like bundling all that data directory that contains my font into the application, and I can access that without like having to give the application special permissions. So I'll just open that file here like that. Let's see the name of my font. Is that. So let's make a string here. I have to give him some permission. So file access, and we only want to read, and we don't have any special open flags. And then I will create my font from that file. So font equal OC font create from file. I'll give that file and I'll just load some Unicode range. I won't load like the whole file. Like that. So see Unicode range. That should actually be an array. So here, so we have our font, should compile. Okay, and we'll create UI context. UI equal, see UI context create, and we'll pass it the font. So now I need to pass all the input events to my UI so that the events are processed by the UI system. So I have another handler that's just call with raw events. And I'll just use that to pass that to OCUI process event. And I have to tell it that it's passing to my context. So use UI context, well, set context. Okay, and so now we can also set the context present on frame refresh. And we can have a UI frame here. That's the size of the whole screen. So here we'll have our widgets, and then I want to render the UI on top of the rest of the drawings. So I will just go there and say UI draw here. And hopefully we should see just the background of the UI, which is like opaque, so we don't see the drawing below. So let's just set some styling here. So I want to set the background color of the whole frame to transparent. And I'll just add like a panel on the side. So let's see, I will have a UI box. That's my panel here. And let's do some layout. So maybe I want some margins. Like that. Okay, now I will set the size of my panel. So let's set the width first, and we'll set it to some number of pixels. And for the height, maybe I want to I wanted to cover the whole size of the parents. So 1 times the size of the parents, and let's set the roundness to something like that. Okay, and let's finally set the color. To something translucent.
Mm-hmm.
Okay, so I should have a translucent panel here where I'll be able to add widgets. So let's set up some layout for that panel. So I want to set the axis here. Axis Y. And let's also set some margins and some spacing. And now I can add some widgets. So let's say I want to change the size of the smiley face. So size label, and we'll call it, well, radius label, say. And now I'll have some slider. And then sliders are like currently they are going to from 0 to 1. So I'm just going to do a little thing here. So say radius ratio equal 0.5 and have that being like 100 plus radius ratio times 200. And I will change radius ratio with that label here. So let's see what happens. So I have my radius here. I can expand the head. That's like, okay, let's quickly do something to appease our OCD times radius and stroke width will be 30 over 200 times radius. So what? Oh, semicolon missing.
Ooh, we lost our eyes.
What? Oh yeah, okay. I knew I would. Yeah, I knew I would give.
Oh, is this a C moment?
Yeah, it's a C moment. I knew I would give Zig people way too moxie. Let's pretend I did it on purpose. I think that's it. Maybe that should be it. Yeah. Okay. Yeah, I was just like integer. Okay, that was amounting to 0. Okay, so that's good, and now we have our eyes and our smile, and that's great. Let's add another thing like another widget. So let's say I want to have some control over the weight. And so in my acceleration here, I just say 400 times weight. Copy that. Okay. Okay, so I can increase the weight, or I can just decrease it and make the thing just fly and bounce on the walls. So that's the basics of the UI. And now one interesting thing that may be different from other immediate mode UI is our styling system. So let's say I'm super happy about that complex control panel, and I want to extract that into its own component. So let's say I would replace that by a function call, basically, to control panel. And well, just checking that it does the same thing, indeed. And so now in most immediate mode UI, the way you would style thing is you would have maybe a style stack. So you put styles on a stack, and then widgets use the style that on the top of the stack to draw itself. The problem with that is that when you want to have like reusable controls that are composed of smaller widgets, you can't really do that with a style stack approach, because let's say I want to style only that radius label. If I push a style here from the outside, it will be overwritten by whatever it's pushed downstream. And conversely, whatever I push here will apply to everything downstream that doesn't push the style itself. So if I want to reach for a specific label, I can't really do that with a style stack unless I also have access to that code and I modify and I push there. But that kind of prevents composing widgets into more complex widgets and having reusable components like that. So we have another way of doing that in Orca. So first, you can like set the styles directly inside the boxes by using these style set functions. But we also have what's called style rules. So you define a rule like that with a pattern that will allows you to match some set of boxes in the subtree of the box you're defining the rule in. So let's say I want to color the radius slider. I want to color the thumb of the radius slider in red. I would select the radius slider with that, and the radius, like the slider itself, is composed of simpler boxes, and there's one that's called thumb. So that would be the pattern I would use. And here I can use the style setting functions as before. So let's say I'm setting the background color of that to red, like that. So that thumb and only that thumb is style and not the other widgets. And I didn't have to push style inside my reusable component. You can also like select sets of boxes. So boxes have tags, and conveniently sliders have the slider tag. So for a tag, I would say dot slider, for example, and this should style all the sliders, thumbs that are inside that control panel. Okay. And you can also like tags there are tags that are automatically added to the boxes depending on the state of the boxes. So if I want to color only the thumbs of sliders that are hovered, I will say dot slider dot hover thumb. And this way, it's only when I hover the whole slider that the thumb is colored in red. So that kind of gives you an idea of how you can select sets of boxes and style them. And it's kind of like similar to like the pattern matching thing that happened in CSS, but it's still completely immediate mode and imperative. And you don't have to fit that into like a declarative style sheet or anything. So yeah, I think that's about it for the UI demo. One last thing I can show you, maybe that's maybe interesting, but it's very work in progress. So let's see if I can show that. I just have to rebuild the runtime with the port for the feature I want to show.
Okay. In the meantime, while it builds, Let me say one thing to the people watching. So if anybody has questions, feel free to type them up in chat, and we'll look at them. I will look at them and then relay them to Martin when the time is right.
Okay, so now I have my application built with the latest runtime, and I can actually show you the work in progress on the WebAssembly debugger I'm working on.
Right.
So here I have all my source files, including all the source files in the SDK. I can see the sources. I can set some breakpoints in there. And you have a call stack. You have variables, but like values are only for paying customers. I'm in the process of parsing all the dwarf stuff to get the locations and actually get the values of those things. But you can step around.
Okay, so you can also step in the in the SDK.
Yeah, you can step in the SDK. Like you can see like what that vec2 add function does. And you also have a symbol view where you have all the symbols in the WebAssembly module, including all the symbols of the libc and stuff. And you have a bytecode view, and you will notice that it's not really WebAssembly bytecode. It's our internal bytecode that we compile WebAssembly to. That is for a register machine, so you can see registers changing there with those types. So yeah, that's the work in progress we're doing in the debugger.
Just to clarify this for people who are watching, because I played with Orca. I think it was like a couple of years ago by now, maybe even. Like in the very beginning, and I was trying to port to Zig without bindings, without anything, a sample application that they have where they showcase all the widgets that Orca comes with. And the point is that once you create your application logic is a WebAssembly blob being run by a runtime. So even if you run your entire application under a debugger, like a native debugger, like LLDB, for example, what happens is that you will step through the host program, not your logic, which is a WebAssembly blob. So that's why Martin needs to make a custom debugger for this.
Yeah, and that's the thing that generally annoying with WebAssembly and with VMs in general. Is that you can't really use native debuggers, and I don't think many the WebAssembly runtime have debugging tools. Like maybe some try to put that work to LLDB, but by compiling to native code, and they have to also like modifies the dwarf information that's made for WebAssembly so that LLDB can pick stuff from that. But
I think browsers have the ability to do that.
Yeah, but they also, I think they also have like custom debuggers for that. And so if you're outside of the browser, you can't really debug WebAssembly unless your runtime has an integrated debugger.
Yes, definitely.
Yeah, so I think that's it for a demo.
Okay, so people, okay, we've shown people. I'll pull you up as a. Okay, now I'm hiding your desktop. You're now big zoomed in. So so you've shown that you can make animated vector graphic stuff. You can show that you have a immediate mode GUI framework that comes with the system. So like if we were to compare this with, for example, I'm thinking of another random WebAssembly runtime. So like WASM3, with WASM3, you basically just get something that gives you access to the CLI. Like you have print, read, maybe. They have maybe WASI to imitate POSIX system APIs. And that's kind of it. So I guess the question is, and maybe this is related to a question that is in chat. So Task3 in chat is asking, any particular reason Orca is a WASM runtime rather than targeting native? So I guess the question is basically, you basically are reinventing a lot of things that you can do native if you want to. But what is the key difference between doing them this way versus doing them natively?
So maybe first, the code I'm using, like I'm showing there, is actually like code that you can also use natively, like the runtime for Orca, and for example, like the debugger. Debugger window is actually like rendered on the native side.
Okay.
So we have exactly the same kind of APIs that work both on the native side and on the WebAssembly side. The idea for having the user code run on WebAssembly is for portability and sandboxing reasons. So by targeting WebAssembly, you can basically completely avoid the problem of cross-compilation, and like your stuff is portable on whatever architecture, given that there's a suitable runtime for that architecture. And also WebAssembly is a format that you can easily sandbox. So that's the two main reason, and it's due to the fact that we want in the future WebAssembly to be a way to get applications from random places on the internet and being able to seamlessly download them and run them without having to fuss with like whatever different versions of the apps for different operating systems, and without having to worry about whether the application will just take control of your computer or leak your data or anything.
Right, because the point is, the premise that we were mentioning earlier is the web is extremely convenient for distributing applications. Too convenient, because it's convenient to the point that the document model has been stretched to become to support full-blown applications. It's kind of funny if you think about it, that you have full-blown like text editors, like even web page editors implemented in the browser, which is weird because normally, when you have like an editor that creates an artifact, there's usually like a very clear direction towards complexity. Like the thing that makes a thing is more complicated than the thing it makes, right? You don't have music making tools inside of music files, but you have full-blown Office suites inside of HTML and JavaScript, which is crazy. So the idea is that is super complicated, and so, but at the same time, the promiscuity with which you can just click on a web page and then the application loads is nice, partially because it's sandboxed. So that's what you're recreating in Orca.
Yeah, that's what I was alluding to at the very beginning, is that we want to keep those benefits, right? It's pretty cool that you can just visit a web page and start using the application right away. Whether on a native apps, you would have to select like the correct version of that application for your operating system and download that, and then double click that thing, and then click through a bunch of stuff like that the OS tells you, oh, you downloaded that from the internet, is not safe, and so like the installation process is not straightforward at all. And also, like, once you have installed that application, you're really putting a lot of trust in a lot of places. Like, you're putting trust in the fact that the developer of the application is not malicious. You are also like trusting that the application doesn't have flaws that an attacker can take advantage of, and you're also putting faith into the fact that the link from which, like the channel from which you got that application, is not compromised. Whereas in the browser model, as long as you trust your browser, that's pre-installed in most cases. So really, as long as you trust the basic operating system installation, you can go to a random web page and start doing stuff without worrying too much, let's say, about being pawned and having your data leaked or anything. Given that you trust the browser, which is the big if, because the fact that browsers are so complex and so monstrous beasts with lots of different technologies piled upon each other means that there is a high potential for flaws and for actually not fulfilling that promise of sandboxing. So yeah, the idea is we want to keep those benefits, but we don't want to drag along a whole browser engine. We don't want to constrain all application to use a document model that's not made for application. We want to have a platform that's layered completely in the opposite way. We want to flip the web stack upside down and have the application model at the bottom. And then you can build document models on top of that, but then it is at the right layers. Like, not every application needs to use the same document object model. Some don't even need a model. Some need another more customized model. And that would be made possible by having a stack that's layered correctly, with the ability to run sandboxed application at the bottom and then everything on top. And a kind of an illustration of that we are trying to build Orca in that way. And an illustration of that is, say, the UI system is built on top of the vector graphics system, and if you had like a document object model or something, like the viewer you would write for your document object model would be written on top of the UI system. And so you have a way of layering things from the low level to the high level, and not having that extremely high level concept of a document that's at the very bottom of the stack and that's constrained everything else.
Yeah, and there's SVGs in there.
Yeah. Yeah, and for example, like the canvas thing in browser, like everything basically in browsers seem like an afterthought. Okay, you have like you have some UI elements that you can put in your web page, but then you are, oh, well, maybe we want to give some more freedom to users, to developers to do more stuff. So let's put canvas in there. And so then people use the canvas to do some UI. So you have like application where half the UI is like the HTML like buttons and stuff, and half the UI is done in the canvas, but is not recognized as UI by the system. So you have all those kinds of impedance mismatch and things that are not really working together, because there has not been nobody has put in the work at rethinking the base layers and saying, okay, yeah, well, maybe that made sense to have that document model at the beginning. Know that we are doing like dynamic media and full-blown applications. That doesn't make so much sense.
Right. So there are then, so to, I guess, kind of recap, there are some serious concerns when it comes to, let's say, at the very least, when it comes to performance, because by having the stack defined in such a weird way where you have high level stuff at the bottom and then you reinvent on top of it, you in some ways maybe even you mimic low level stuff at a higher level, and you have like this weird soup, then performance is a huge problem. At the very least, you also have extra complexity. So the idea of Orca is you don't do that. But I think it's also interesting from a, let's say, more high level perspective. The idea that I would say that Orca in some ways seems to me like a, not exactly necessarily the opposite, more like an inverse Electron, where the idea is that Electron runs on your system, is the host application, and if you're very naive, you might think that the two things are very similar. But the idea is that Orca pulls in all that soup into your quote unquote native application. And so you keep the sandboxing. Actually, maybe, I'm not even sure, because I think that Electron applications have a ton of native extensions. And then you still have the performance problems. And then you still lose also the browser interoperability. So people in chat, I think it might be worth bringing up a high-level point that we wanted to keep for the final part. But maybe it's a good idea to talk about it sooner, because people in chat were wondering about how exactly does the app distribution end up working out in the end, because since we're talking about sandboxing and the ability to even be willing to run untrusted stuff, if the way you package application is as an application that contains also the runtime, then you will potentially get a funky runtime that you shouldn't trust. So I think we should talk about the plans for the launcher.
Yeah, so that also resonates with what you just said about Electron, and Electron has exactly the same problem, right? Because they just ship a whole browser with the application, but then that browser engine could be compromised. Yeah. And so if you're gonna ship an application that bundles like the user executable, so to speak, and the runtime that's in charge of sandboxing, the sandboxing point is completely moot. The reason why we have this model currently in Orca is like there's several reasons. So one is that it's easier during the first steps of the project to have that model where we just ship standalone application. We bundle your assembly module with our runtime, and we produce like an application for macOS, an application for Windows, soon an application for Linux. And these are standalone applications. That allows us to focus on the application building tools and on the system APIs, while still keeping in mind the sandboxing part. But we are really like trying to make something that's immediately usable, like immediately useful, because the problem with the browser model is that to run the application, you have to have a browser. That's not a problem for browser because they come pre-installed on operating systems. So people just don't think about them. But if each time you had to visit a web page, you had to download an application to view that web page, that would be a problem. So there's a bit of a chicken and egg problem regarding adoption of the system. And a way to shortcut that, like to work around that, is to first have the Electron model where we produce standalone applications. So from a user's point of view, it's like they don't have to know that it's Orca behind. And we are just like developing the tool that make developers want to use the system.
Right, because the selling point in that case would be that you're a developer who does not want to go the full length to implement native versions of everything for each OS, right? Because it becomes complicated once you pull GUI into the mix. As long as you're making a CLI application, maybe it's not that hard. You don't care. I pulled it off with Zine, but once you have GUI in it, then it quickly becomes kind of a nightmare. So if you're not willing to go the full length, you can use Orca. You target Orca, and now your GUI application runs decently on all OSs.
Yeah, and you like you know, so you have that confidence for yourself that the mistake you may make in your application will not be fatal flaws if you ship a correct runtime. That's not something that the users can rely on, but that's something that developers might still find valuable. But yeah, the main selling point at that stage is that you build your different applications, but you always use the same code. You're just targeting a platform that is Orca.
Yes.
And the other selling point also is that we want to have all those tools, all those debugging and profiling tools, and I want to make them as good as possible so that it will actually be better to develop Orca application than to develop native ones. And the WebAssembly and having a VM actually gives us some opportunity for in that area, because we can have a much more runtime that's much more aware of what's going on at the execution level, and so we have an opportunity to have better debugging and visualization of what's happening in your executable. So I think the tooling is also a selling point, even at that early stage where we are still in the Electron model. And also, of course, another obvious benefit is that you're not shipping like a whole browser engine, and you're not tied to it, so you don't have to mess around with JavaScript and CSS and stuff like that. But that's only the first stage of the project. And then when we know the shape of the runtime and its APIs and its tooling, we can propose another approach, which is having a launcher that will centralize the runtimes and share the runtime between different Orca applications. And so the idea is that it's actually the thing I did at the very beginning of the project for when it was a Jam project. I just had it like a window where you could put a URL in there, and it would download the WebAssembly module from that URL and start executing it. And you can have that working in a transient mode where you click that link, you get that Orca application running, and then when you close it, it's gone. Or you can cache the application in a kind of local library to use it offline, and you have a browser with your Orca application, and it would be the way to distribute Orca applications. So you would just send the WebAssembly module along with resources like fonts and images and stuff. But the user would have that launcher that has runtimes, plural, in it, that could give a runtime to that module and run it. Why I say runtimes plural, it's because it's also a way that we can tackle the problem with backwards compatibility. A lot of problems with browsers boil down to absolutely wanting to not break backwards compatibility and to never really rework things at a lower level. And necessarily, I think a system that ties itself to that promise of not breaking backwards compatibility cannot avoid complexity creeps, because you will make mistake And so you will have to, if you don't want to just tear things down and break compatibility, you will have to just, you can only add things and never remove things.
Yeah.
So you will add workarounds on top of workarounds, etc. And you won't be able to clean things up, and that's entirely necessary to fight complexity. So having a launcher that has several versions of the runtime and that's attributing the correct versions to a given Orca application means that you can actually break compatibility between runtimes, because the launcher will just like pick an old runtime if the application is not compatible with the newest one. And at some point you have to, like, it gives you some margin. At some point you still have to break compatibility, because, for example, if a runtime has critical security flaws, you don't want to use it anyway. So at some point you will have to break compatibility, but it affords you some leeway in the way you tackle this problem.
That makes perfect sense, and it's so cool. I also agree wholeheartedly with the point that there is no way you can promise forever backwards compatibility and not be bad. Because I would even argue that even if you don't make any mistake, like even if you do literally the best possible job ever, even in that corner case, extreme case, you still have the problem that like needs change over time. Like you could even argue that not having a canvas in the original document model was fine, because originally it was meant to be documents, and then those needs changed, and then that's why things. Well, you know what? Maybe it's a bit of a not the best example, but the point is, people's need change over time. So like you want to do the right thing that makes sense today. You don't always want to do only what will make sense for the next 100 years, I would argue. So if you want to tackle today's problems, then you will also need to put yourself in a situation where you can then let that go once those things are not a problem anymore, so to speak.
Yeah, exactly. And and that is the big question, right? How you manage that complexity, and that is like, so it's really easy at the start of a project like Orca is at its early stage. It's really easy to say, oh, we are less complex than a browser. Like, of course, but if we follow the same path, we are bound to develop the same kind of complexity. So we have to kind of imagine ways of cutting that complexity down and keeping it in check when times move forward.
Yeah. This discussion has been very interesting for me. I never had any love for Electron, but man, do I despise it now. Because what drives me nuts is that not only is that thing resource hungry and janky, and while I get why people, I understand why developers pick it. I get it. I could see myself one day decide to go with Electron rather than take on all the responsibility of doing native versions of some kind of application. I get it. But man, is that thing bad? Because on top of everything, if you think about it, Electron throws away it's still a web technology, and it throws away the main advantages that you get from the browser. And you sometimes feel it a little bit, right? You feel like the tension, for example, between having Discord installed in your system versus running Discord in a tab. And it sucks. It sucks in so many ways. So like you basically by for example installing Discord natively air quotes natively, you gain some things, right? Because the Discord in the browser is also kind of jank, especially if you're using Firefox. But me versus Firefox, that's another story. But then when you install the native one, like you lose certain things. It's incredible. It's incredible how bad of an idea that is. So yeah, that's really interesting. So I hope that people in chat had an opportunity to really understand the perspective here. The perspective is you can even argue that software distribution could be better in the sense that native application software distribution is not as good as it could be. The web has shown that it could actually be better with the right preconditions. The problem is that the web stack is definitely not shaped in a way to support, applications. And it's getting stretched to do that. So there's definitely like an opportunity to make things better going forward. I think that the world could use, I think, something that makes application distribution more fast and like more lightweight, kind of like the browser did, except it's apps, real apps, and not web pages.
Yeah, and when you think about it, there's nothing that says that these features should be linked to browsers, right? Like the browsers seem good only because operating systems suck, because they should be the one that tackle these issues, right? They are there purportedly to run applications on your machine and to distribute resources on your machine to different applications and to isolate application. That's exactly their job, to make it possible to safely run application on your machine. They should be the one that allows you to just seamlessly run an application without having any install step, like any visible download and install step, and without giving them like all the keys to your kingdom. They don't do that. So we are kind of doing the work that they should do. And I mean, so there's these two steps we talked about, like the Electron model, which is like a way to bootstrap the project, the launcher/browser model, where basically you regain all the advantages of the browser, but with a better stack. But we can go like a few steps further, and like the third stage is more like going towards an operating system-y thing, where if you have multiple applications that are all sharing the same formats, that are all using the same runtimes, that are all organized in the same library, then you can start thinking about system-wide services that Orca could provide. So like really simple example is like when you have an operating system, you have these kind of system-wide things. So you have searches, you have the clipboard, little stuff that allows the application to interoperate and to interact. And we could do much more with these kind of WebAssembly application, because it also gives us some way of dynamically composing applications and the opportunity to rethink how we make applications from other applications, how we give users the possibility to, for example, make their own little pipelines for tasks they have to run often. All these kind of questions that are not really tackled by operating systems today. And I think there's an opportunity for a lot of interesting things to be discovered there. And so that's kind of the third stage of Orca, is making it more like a platform where we can have composable application. We can have links like on the web. We can have transclusion. We can have applications that are embedded into each other. So for example, if you had like a viewer, like a document viewer, and let's say it's like a text editing kind of application, and suddenly in your document you have a section that is like tabular data or like a spreadsheet or something. You could like use the future equivalent of what an iframe is today to just like include another application that's a spreadsheet editor to allow you to view that data in line. And instead of every application being like confined in and having like this constellation of isolated application like we have with web apps today, but also like with the Electron model, we could have a much richer ecosystem where application can actually interoperate and take advantage of the features exposed by each other.
Yeah. Yeah, I think this is interesting because if you, for example, the sandboxing aspect, some of it is being tackled by OSs. For example, you know what, Windows, I have no idea what's going on with Windows, so I'll skip that one. But like Linux has, like I'm thinking of Ubuntu. I forget the name of the technology, but there's like a way of like packaging applications in a very self-contained manner. macOS kind of does that by default because when you download like an app bundle, you don't really have like an installation step. Like installing an application tends to just be you drag it into the applications directory.
You still have like a silly step where you have that image thing and you have to drag the thing. Like it doesn't really make sense.
To be fair, you don't have to do that. Like you could argue that by not doing that, you're running the application in an ephemeral manner. But regardless, there is something there, right? But yes, also the interoperability stuff is something that is kind of not happening anymore with OSs, right? I think there was a bigger push in the past maybe to make this stuff happen. Abner is mentioning in chat objects on Windows, and I also have a vague remembrance that was supposed to be what they could do, right?
Yeah, and I mean the thing is for objects specifically, or so there is this idea of like components that you can use. I don't think like the granularity is the right one. Mm-hmm. I don't think you really want to expose like classes or things like that and make them interoperate. But there's definitely something about the power of like interlinking and transclusion that is something that's hinted at by the web.
Yeah, because even though OSs don't really do this thing anymore, I don't know if they ever did, but like in any case, maybe that was something that people thought it could become a thing in the past. Lately, doesn't seem as much anymore. But the web has plenty of examples where this happens, right? Like you have, for example, Google Maps viewers everywhere. Like every time you have a map thing, or like YouTube videos that become embedded in your page, right, etc., etc.
Yeah, and even the web is not how to put it. So in previous like visions of what the web could have been, like mm-hmm. if you go back in history and think about like the work of like if you go way back to 45 when Vannevar Bush was talking about his Memex, which was like a kind of virtual library that everyone would have. And he was kind of explaining, okay, you can have all these documents in your kind of desk that you can recall at the press of a button. And you could, that would be a good idea to like create trails between those documents. So he was essentially describing hypertext at that time, like way before it existed. And when you compare that vision to the actual web we actually got a weaker version of that, because when you think about it, like links on the web are just like one-way thing that point to another. Whereas there was a lot of thinking back then about richer IDs of hypertext. And for example, in Van Bush case, there's this idea that you can have like two-way links between documents that form trails that kind of mimic like the train of thoughts you have when you're browsing those documents. And like everyone would be able like to produce those trails and to share them with other people. And so you could share your trail of thought with someone who could take that and expand that and branch off and share that back. And like the web that we got at the end of the 80s is really less powerful than that. And we kind of stopped thinking about that as if, okay, the web, that's it. The web is what we got from Tim Berners-Lee, and we can't do more research on that. And I think there's still potential in there, especially like inside an OS-like environment where you want to have more dynamic links between different documents, between different applications, etc. So that's very much like an area of research that I want to explore. And Orca is like, I think, a good vehicle to explore these ideas.
Nice. That seems very interesting. I was also thinking as you were talking about like application update. Another characteristic of the web is that every time you refresh the page, you're basically quote unquote installing the newest version of an application, which is not always desirable because sometimes there's nothing for you to gain with a new version of an application and only stuff to do's. Boy, do I know that. Every time any of my streamer setup wants to update, I don't like it because it works. I'm happy with it. Any change will not give me anything that I want, most probably, and is only likely to give me stuff that I don't want, like breakages and stuff like that.
Yeah.
But at the same time, I think it's interesting also to have the ability to push updates more. Well, let's not say push. Let's say pull, for the user to pull updates more quickly and more seamlessly than it is today with desktop software. So I think that might be interesting, being able to do that let's say in a more standardized and like transparent manner, rather than having like Discord that keeps updating itself 10 times a day whenever it wants, or on Windows having, man, I have no idea how many stupid updater applications I have running in the background on Windows that are like spasmodically looking for newer updates and like burning data and CPU cycles just so that, you know, the like I totally need the latest NVIDIA driver, the fucking mouse. The fucking mouse wants to update itself all the time. It's like, dude, I'm fine. It works. It's like it's moving an arrow around and it's doing it fine. Please let me be.
Yeah, and it's also weird that like everyone is kind of doing its ad hoc update path, and like with ad hoc services that are like constantly like checking with their father server whether there is an update to pull. That also should be like something that an environment or an operating system should do. And for the Jam version of Orca, I had something. So you would visit that URL, get the application, and you had just like a kind of download button, and you click on that, and it put that version of the application on your local library. And so then you can use that even if the developer updates the app, it can't update behind your feet.
Yeah.
And if you want to update, you just click that download button again, and the app updates.
Yeah.
So you're more in charge, and maybe there should be some updates that are managed by the runtime, like for security issues, for example. But there are more updates that pertain to the runtime itself, not like every little application deciding when they want to update and in which way they want to update.
Tell me what you think about this idea. So one way that it seems to me this could look like is, I'm about to say a bad word. I apologize to you and the people in chat listening, but I almost imagine like a good way I think this could work is with RSS feeds. The idea being an application tells you an RSS feed. It doesn't have to be RSS, but you get the idea, right? Some kind of syndication system, and it tells you that is the location where information about updates will be present. And so when a new update comes up, it shows up there. If the user wants the application to update, so like you set that in like the application options, you say, yeah, I want this application to always be up to date, or no, I don't. Then the application maybe will auto-update if the user wants so. If the user doesn't want to, they can maybe get notified and decide if they want to do the update. And I think also interestingly, if you have a system like that, where the idea is that the RSS feed has an entry for every new version, but it doesn't lose all version entries. Once you find out that I don't like this update, it regressed the feature that I was relying on, you can roll back. You can say, you know what, bring me back to the older version.
Yeah, so another idea I had was basically versioning the applications, but locally, because if you have that syndication system and you have that possibility to roll back to an older version, it really relies on the developer maintaining that log, and like keeping these old applications online, and so it would still give the ability to the developer of just pulling the rug under your feet and just forcing using the new application because like the old one wouldn't be available. It should be possible to version the application locally, especially if all you get from the application is just like the WebAssembly module and just the application specific logic, and you wouldn't have to pull like the weight of like all the graphics backend and the UI backend and so on. So it might be entirely manageable to just version like some number of version of the application locally and give you the choice to roll back, and that's something you could control, like how many versions do you want to keep. Do you want to just like I think the most important thing is just have the ability to go back to the last version you liked, so the last one you bookmarked, so to speak.
I'm trying to think about it a little bit more. Maybe I do think that I understand the adversarial relationship between software developers and users. Well, not fully adversarial, hopefully, but sometimes to some degree. I do think though that it might be nice for that to be a thing that is expected of developers. From this perspective, like for example, I think that people pointed out to me in some discussions that whenever they make, for example, music using, applications that you can use to, you have synthesizers and then like you make, you put samples together and you make music that way. And they were pointing out that the problem with those systems is that every time the application updates, well, not every time, but sometimes the application updates, and then you have a file, a project generated with an older version, and now that doesn't work anymore. So,
oh boy.
Right. Okay. So you know about this stuff. You found that pain too?
I was I started as a sound engineer, and so I know exactly what you're talking about regarding like sequencers and DAWs and stuff like that. And versioning was like a big problem in studios.
Right.
Yeah.
And so I think it could be nice to say, a serious application that uses this system has this standardized manner of saying, like, the idea is you don't pull old versions down unless you really have to. And so that way you can more leisurely as a user say, here's my file, I made it with this version of the software. And so another, quote unquote, unsuspecting user can just select that from a drop down without necessarily having to also somebody having to make sure that they archive the older version because it might go away. I mean, maybe archiving it could still be a good idea if if you just want to be sure. But still saying, this is part of the ecosystem. Not everybody's gonna do it. Somebody's gonna be maybe naughty or like not they're not gonna do everything that they should be doing. And so in that case, maybe there is a escape hatch where you save a copy of a particular version of the application. But in general, the concept of being able to roll back to previous versions is a expected thing. It's expected service from developers to the user, because this is also interesting. By the way, this discussion is making me mad about more and more things all the time. So I'm mad about Orca now. About Orca, about Electron. The next thing I'm mad about is software that is given to you as a service that keeps updating under your ass, breaks backwards compatibility to things, because it does sometimes, and there's literally nothing you can do at all. And the point is that from their perspective, they don't even think it's something that they should offer. Right? There's not even an option to like shame them about this behavior, because it's up to them to decide. It's not like the internet implies that they should keep the older version of the application available to you at all.
Yeah. So I think, from a pure technical standpoint, the platform can't really force developers to behave in a good way.
Yeah.
No. Because like, even if you have all these like local first features, if developers want to be, if a developer wants to be an ass to its users, it can still have like the application talk to a backend server somewhere, and if that's not the right versions, like suddenly everything breaks. Yeah. So there's really no way from the platform point of view to
fully protect the user.
To fully protect against that. But that doesn't mean that it shouldn't try, and that it shouldn't provide the tools to do the right thing, because it also sets incentives, and it also sets like kind of social pressure, and set what's expected in this system. Like, if everybody knows that it should work, and that there's no like technical reason for it not to work, then it's a bit harder for developers to not follow those agreed upon norms.
Mm-hmm. Yeah, that's interesting. I think I got mad at another thing also in the meantime. I think I got mad also at like the, what do you call it, like the app marketplace. The heck is this thing called? The App Store. Goddamn.
App stores.
Yeah, the App Store. Because to some degree, the App Store is offering these features. Again, to some degree, but it's still not as nice as it could be. I don't get, like, I'm thinking of, sometimes I turn on my phone. Well, I turn on the screen of my phone, and I see that the application that I want to use is updating, which I hate when that happens.
Oh yeah.
And you don't get to rollback in app stores either. I think they keep all the versions around, but I don't think you get to rollback.
Yeah, no, it's kind of hard, and also like the app stores, like they only streamline the installation process really. They don't do much in terms of sandboxing, because like once you have installed the application and give them like all the permissions, you have to give them like up front without knowing what the application is doing. The sandboxing is out of the window, and you really have to trust the advantage is you don't really have to trust like every individual developers. If you trust the App Store to do some curation on the app they sell, but that's the thing they never seem to do.
Yeah,
Like
they don't do a
they
great
just
job.
like, okay, we can sell apps. They won't look into what the apps are doing.
Yeah.
And like even with the notarization stuff on Apple, like of course they don't verify that the app is not doing something nasty. So yeah, it's really just jumping through hoops they put there, but that doesn't buy you any guarantees of any sort.
I'm getting mad. You know what? Now that I thought of the idea that I could have like a system where I can right click on the application and like maybe not necessarily by right clicking, but like figuratively speaking, the fact that I can right click on an application and say show me the available versions and give me, and I decide when I want a new one or not or rollback, it's driving me nuts. Because that could actually, jokes aside, that could really, like, for example, I was mentioning my streaming stuff updating. Sometimes OBS updates. I like OBS. It's a good project. Updates tend to be fine. But I have a couple of plugins, which are dynamic libraries. And those plugins sometimes, I don't know whose fault it is, because I would hope that OBS has a stable API for those. Maybe it doesn't. I don't know. Maybe it's the plugin creator that is doing something that they shouldn't do. But sometimes those things flip out when I update OBS. And so one time I was naive about it, and I updated OBS right before starting a show, and I was kind of going insane, right? Because I got my entire system
big mistake.
Yeah, borked. And so at that moment, having the ability to say, "Oh, you know what? No, never mind. Right click, select the other option in the drop down. Oof, okay, we're back, and now I can update later." It's insane that I don't have that. There's no reason for me not to have that.
Yeah, and you should like. I think you should be like as a user of an application, like whether it is something that's free or whether it's something that you bought, you should be in control of that. So yeah, you should have control. You should be able to use the application offline as much as feasible. Like some application will need some connection because they need to talk to a backend or something. Like if it's like, I know if it's an application for buying stuff online, like of course you have to connect to some DB somewhere, but most applications don't need that, and you should be able to use them locally. And even for those applications that sometimes need to talk to a server, you should also most of the time be able to use them locally and then just sync to whatever services they need online, like when you decide to. That shouldn't just like prevent you from ever accessing the application, which is the case if you have like a browser and like if you're offline, you just can't access the application, right?
Yeah. Man, I can't wait when somebody will have the genius idea of implementing Electron on Orca.
Oh boy. Yeah, and we can continue like making tower like the towers of Hanoi, but like with with software. And that's really all we seem to be doing in the software industry, is like piling stuff on stuff. There is a good Monty Python sketch of the society of putting stuff on other stuff. Yeah, that's a problem.
Nice. So we jumped ahead with a high level discussion, but that was very entertaining for me for sure. So, do you want to talk about the things that you did with the Vector API?
Yeah, sure. Yeah, I can explain a little bit about it because well, it might be interesting to the audience. Just let me take a tablet there. I'll maybe draw some stuff. Okay, and is my screen still shared?
It is. Yes, we're seeing it.
Yeah, cool. So let's turn that thing on. So yeah, I think we saw the example of the API. So basically, you can define path with lines and quadratic Bezier curves and cubic Bezier curves, and then you can like either stroke them or fill them with different colors. You can also like have textures or gradients in there. So from the API side, it's like a classic Canvas API where you move your virtual pen around to define path, and then you fill them or stroke them. But then the implementation of that can get quite complicated. So I mean, just cut me off if I get too much in the weeds. But the idea is that you have some kind of path like that. Let's zoom out a little. Okay. So let's say you have. Isn't that not working? Okay, sometimes it does that.
Electron moment.
Electron app, yeah. And yeah, this thing also updates. So let's say you have like a kind of path like that, whatever. And it can be like arbitrarily contrived, like it's not convex, it can self-intersect and have holes in it. But that's the path you decide to fill. So the idea is that you want to know if a point is outside or inside the path. And the way you do that is by computing what's called a winding number. And the idea is that you will draw a line that goes from that point towards infinity along a given direction. And you just count the number of crossings. And your path is oriented. So let's say it's oriented that way. So here, for that point, we have like a crossing down. So that's -1. Crossing up, that's +1. Down, -1. And +1. So the winding number of that point is 0. And for that one, we have a crossing up and a crossing down and a crossing up. So the winding number of that point is 1. And basically, you have 2 rules you can choose from to determine if the point is inside or outside. So you have what's called the non-zero rule. So that's when the winding number is non-zero, you're inside the shape. So here we are inside, here we are outside. And there's also an even-odd rule. And with this one, when the winding number is odd, you are inside the shape, and when it's even, you are outside. So it doesn't change anything for these 2 points, but the difference between these 2 rules is for areas like that, where you have a self-intersecting path or where you have holes. So for example, if I have a point here and I'm drawing my line here and counting the number of crossings, I will have a +1 here and a +1 here. So my winding number is 2. So for the non-zero rule, I will have, like, my shape will be something like this.
Yeah.
And entirely fill. And for the even odd rule, I will have this with like a hole in it. So the difference is how you treat those self-intersecting areas and how you treat, like, for example, a hole in there that would be like a subpath. So yeah, so that's the idea. But then how do you compute those winding numbers? How do you count those crossings? Knowing that the path is defined by Bezier curves, so it can be a little complicated to compute the intersections. So one thing you can do to simplify that is that you can split those curves into monotonic curves, and which means you want only curve segments that don't have inflection points. So, for example, let's say I have a Bezier curve. So these are my control points. And let's say, okay, I have 4 control points for my Bezier curve. And then it will be something like that. Oops. Take the pen. Okay, so the Bezier curve will be something like that. Okay, and so you basically want to split that into a curve without inflection points. So you will split at inflection points and at points where where the curve isn't monotonic. So you want only pieces that goes in one direction on X and Y axis and that don't have inflection points. So you'll split here, you'll split somewhere here, and somewhere here. Okay. And so one thing you can, one observation you can make with these, so well, to determine the split points, you're looking at the derivatives of the Bezier curves, and you're looking at the points where it goes to 0. So since like deriving, you're lowering the degree of the polynomial. So for like 4 lines, they are always monotonic. Okay, for quadratics, the derivative is a linear equation, and for cubics, it's a quadratic one. So you are only solving degree 1 and degree 2 equation to find those points. And then the observation you can make is that all these monotonic segments, they all fall into one of 4 categories. So it can be a segment like that, or it can be a segment like that, or it can be a segment like that, or a segment like that. And let's draw the bounding boxes of those segments. So only segments that grow uniformly on each axis and don't have inflection points. And we'll name them, and I'll name them depending on the corner towards which the curve bends. So this will be a northwest segment because the curve bends toward the northwest corner here. This is a north east. This is a southwest and a southeast segment. Just to name them. So here it's pretty clear that when you have a point above or below or on the right of the bounding box, they can never cross. Like the infinite lines you draw can never intersect with the segments. And conversely, when you are on the left of the bounding box, you always hit. So now you're left with points that are inside bounding boxes, and let's draw some diagonals here. So if I have a point that is on the right of the diagonal on a north, west, or a southwest segment, it will never cross the segment. And conversely, if I'm on the left of the diagonal on a northeast or southeast segment, I will always hit. So now I only have to evaluate the side of which side of the curve I'm in. If I have a point on the left of the diagonal on a northwest or southwest segment, or if I'm on the right of the diagonal on the northeast or southeast segment. So that's basically reduces the number of cases where you actually have to evaluate the curve at all. And to evaluate the curve, we use what's called implicitization, and that has been worked out by Loop and Blin in 2005. And the idea is that your curve is defined by, it's basically a polynomial, so it's defined by power coordinates. So C0, C1, C2, C3 for a cubic Bezier curve. And implicitization transforms that into a sign and a matrix M, such that if you have a point x, y, z, like x, y, 1 in homogeneous coordinates, and you multiply that by the matrix M, it gives you point k, l, and m. And then I have to look up some notes because I never remember the implicit form of that stuff. But basically, you have two equations. Let's see. For the so for the quadratic Bezier curve, you have k squared minus l times n inferior to 0 will mean that you're on the left of the curve. And so that is for quadratic. And for cubic, the equation is not too difficult either. It's sine times k cubed minus lm inferior to 0. So what you do is you take all your curves, all the curves of your path, you split them to make monotonic segments, and you categorize those segments into one of the four categories, and you implicitize the curve. So you for each one you get the sign and the M matrix, and then when you have a point and you want to see if the infinite line going to the right crosses the segment, you just apply the rules we worked there. And in the few cases where you actually do have to evaluate the curve, you just multiply your point by the matrix M, which gives you KLM, and you plug KLM into those equations, and that gives you if you intersect the segment or not. Okay?
Yeah.
So where do we go from there? So the naive algorithm would be like that. You monotonize and implicitize. Then you then you just compute the winding numbers for all pixels, and that is entirely parallel. So you could do it for each pixel in parallel, but you are still doing like a ton of redundant work. And a way to see that is if I have a point and my infinite line there, and I have a number of crossings. So it's crossing down, crossing down, crossing up, crossing down, crossing up, whatever. And that is P1. And I have another point P2 here.
Yeah.
So here is -1, -1, +1, -1, +1. So you can already see that when you're computing W1, it's -1, -1, plus the winning number of P2, right?
Yeah.
because you will hit the
It's
same
one.
segments.
Yeah.
So the winning number is actually like a prefix sum along that scan line. So if you are doing that work for every pixel, you are doing a bunch of redundant work. So the idea would be to have that prefix sum, but that's not a super good idea either, because that makes a dependency on each pixel of the skyline, like that sequentializes all the computation along that skyline, which is terrible for parallelism.
Yeah.
And the other thing that's not really good is that you would have to do it for every skyline, whereas winning numbers have that property of being locally constant, which means that if you have some points in the vicinity of P1, there's a good amount of chance that it has like almost the same winning numbers, and because like it would cross the same path. So so that's not possible to do it that way, but we'll keep that idea of a prefix sum in mind. And the ideal situation for us to exploit this locally constant property of the winning numbers is to like split our space into tiles, and we would want to do computation separately in each tile without caring about the other tiles. Okay.
Yeah. So you're fine with adding maybe some data dependency, but like not globally, only locally.
Yeah. The thing is, we've just seen that it's not possible, like because like computing the winning number is not a local problem, because the winning numbers in these tiles depend on winning numbers in all the tiles on the right. Okay. So the insight here is has been found by I guess it's Nihab and Hope in 2008 is the first paper I see mention that. Is what they call the lattice clipping algorithm. And the insight is that you can clip that path along the edges of each of those cells and end up with a set of paths that together are equivalent to that path. So let me explain with a drawing here. So instead of having that path here, we just clip it along the edges of all cells. And so we would have that path here, that path here, that path there. Okay, so you get the idea. And for all intent and purpose, like these subpaths cover exactly the same area as this path.
Yeah.
And what we're doing is that we are just adding like shortcut segments along the edges of the tiles. And one thing we can notice is that the shortcut segments we are adding on the left are never used, because like if we are testing points inside that tiles, we are just intersecting with the line that goes to the right. So like the leftmost segment has no impact. And the top and bottom don't have any impact either, because they are like horizontal, like they are never like crossed really by. So the only things we are adding are actually like these shortcuts. We are just like adding line segments to our path along these cells borders. So we can be happy about that, but we have just kicked the can further down the road, because you can't really add those shortcut segments locally either. Like you can't decide about them locally. And to be convinced about that, I can focus on that tile, for example. So let's say I have that tile here. I'm drawing. Okay, so the path in that tile goes that way. And let's duplicate that for a moment. Okay, so looking only at that tile, I have no way to know if the path is doing something like that, or if the path is doing something like that.
Right.
So in the first case, the shortcut segment should be that one. Whereas in the second case, the shortcut segment should be that one. Is that?
That makes sense. Yeah.
Does it make sense? Okay. What can we do about that? We can actually always make the same consistent guess and then have a second path where we try to correct the mistake we made. So let's see how we do that. Let's see. I'm gonna draw like a full row of stuff. Okay. So this is a tile I'm interested in, and this is like the row on the right of that tile, and we'll basically have okay, we'll have also like we have a path that's going out of the tile, and we want to know if we want to make the shortcut go to the top of the row or to the bottom of the row.
Yeah.
And we'll basically have three cases. So here and here. Whoops. Okay. So we are dealing with closed path. So if the path is exiting the tile, it must re-enter the tile at some point, and it can do so. It can re-enter the tile from the same edge, or it can re-enter from another edge, but then it has to exit the row first from the top or from the bottom. And so what we will do is that we will decide that we always like join the intersection to the top of the row. So here we will have this shortcut, and here we have another segment that entering the tile, and so we'll have this shortcut. In this case, okay, we'll have this shortcut, and is this one we'll have this shortcut. And here we are making a mistake, okay? Yeah. But when we check the other tiles on the right, at some point we will see that there is a segment here that's exiting the tile from the bottom. And so at that point, we know that we made a mistake for all the tiles on the left. So what we'll do is that when we see that bottom crossing segment, we'll basically add a backdrop here, which is a shortcut segment that will cover like the whole edge of the tile, and we'll do that for all the tiles on the left. And so when we are computing winding numbers, so we are adding oriented crossings basically. So green and red cancel out here. So the equivalent of these three scenarios are this way. So, okay, we have that, we have that. So in the first case, the equivalent to these two shortcuts is that one, which is the correct shortcuts, like the correct way of clipping that path along the cell edge.
Yeah.
In this case, we just have this shortcut that stays the same and it's correct. And in the case below, we are like the resulting shortcut is also the correct one.
Yeah.
Okay, so another way to put it is that we have some local rules. Let's have that. And I'll have that kind of 6 cases. So we can have like a segment that's inside the tile, or like at least like a segment that's not exiting on the right and can goes in a different direction, up or down. We can have segments that are exiting on the right of the tile, going out or going in. And we can have segments that are exiting on the bottom of the tile, going out or going in. Okay, so our local rules are as follows. For a segment like that, we are just adding 1 to all this region. Okay, we are adding -1 to all this region. When we get a segment that's exiting on the right, we know that we are always making the consistent guess of joining to the top. So here, this whole area gets +1. And we don't have to explicitly compute the intersection here.
Yeah.
We just like everything that's on the left and above this segment is getting +1. And for that one, it's -1. Okay. And for the segments that additionally cross the bottom, we know that we made a mistake on the tiles on the left. So we just keep track of those. And then we do a prefix sum like I alluded to earlier. But instead of doing a prefix sum along a scan line, you do a prefix sum along the whole row and for each tile. So basically, you will add +1 to all, you will add -1 to all tiles on the left here. And you will, in this case, you will add +1 to all the tiles on the left here. Okay, does that make sense?
It does.
Okay, so now no, yeah, we can how to, yeah, maybe you can just like see summarize the naive pipeline here, which is okay, humanize and implicitize, that doesn't change. Then you bin the segments to tiles. And here you also like keep track of bottom and right crossing. And then you do a prefix sum on the bottom crossings. And that gives you basically like a bias per tile. And then you do your per tile computation of the win numbers, adding the bias of the whole tile. And that allows you to raster the thing pixel by pixel. Okay. The thing is the name of the game here is trying to exploit the parallelism of the GPU as much as you can. And sometimes you want to parallelize per tiles. Sometimes you want to parallelize per path, sometimes per segment. And the drawback of this simple pipeline is that first, if you have like different overlapping paths, you have to compute them, like you have to compute different winning numbers for each path. So you would have to run that pipeline for each path over and over, and like storing the results of the raster in between each passes, which is not idle. And if you want to have like correctly overlapping shapes, and if you want to deal with transparency, you also have to do everything in order, like to do all the paths in order. And we can do a bit better than that, so I can explain how the Orca pipeline is set up. So first thing, like the first path we have is like a path setup where we want to separate, like, well, let me walk that back a little bit. What we want to produce ultimately is like for each tile, we want to produce a list of operations, and operations can be like a segment operation with an index that gives you like which segment we are talking about, and the segment operation just tells me, okay, compute the winning number of the points for that segment. And we can have AND shape operation, also with an index, but this time an index to the shape that gives you like the attributes of the shape, like the color and the winding rule you want to apply. Is it non-zero or even or odd? And with the AND operation, you also have a bias, which is the result of the prefix sum. So we basically want to have a list of those different kinds of operations for each shape. And we want to separate these operation lists per shape so that we don't have to bin everything in order. So the first step in our pipeline is the path setup. So let's say we have these tiles and we have several shapes in there. So we have a shape like that, and well, maybe let's use another color. We have a shape like that, and we have a shape like that, for example, which are overlapping. What we want to do is treat those separately. So we will, like the path setup, will reserve separate bins for each path. So this one cover a 2x2 area, this one cover a 2x2 area too. So we just like reserve bin for path 1 and path 2. Okay, so then we get to the segment setup part, which is where we do the monotonization, the implicitization, and the binning. So basically what we will end up with is we have our bins here, and in there we will have this, and in there we'll have these segments. Okay, and we will also have marked the bottom crossings. So here and here, and bottom crossings going out here and here. And so you can do that path by in parallel per segments. Like you just throw all your segments and treat them all in parallel, and they know to which path they belong. So you know in which bin to put them. And it doesn't matter the order of segments in a shape. So you can do this all in parallel without being sequential. And so that's the interest of doing that pre setup here. And then we can do our backprop, which is like the prefix sum for each bin. So basically, we are computing biases for each tile. So we'll have +1 bias here, a +1 bias here. Okay.
Yeah.
And then we get to the next phase where we'll just append the bins. So we run through our path in order, and we just append the bin, and we create lists of operations for each tile. So we're back to our whole tiling here. And so we'll have something like that. So we're just appending those commands, and we still know that we have a bias of +1 here and a bias of +1 here. And so, for example, if I focus on this center tile, the op list I have here would be a segment operation like that, a segment operation like that, an end path with a +1 bias, and then segment like that, and an end path without a segment without a bias. So that's my op list. Actually, we can do a bit better than just going through all path and appending the commands by adding something here. So here we'll also have a chunking path where basically we want to chunk our whole cell grid and have chunks that are several tiles in size, and we'll just bin the path in those chunks. So here I know that I have path 1 and path 2 in this upper chunk, and in the other I have only path 2. Okay, so this allows me, when I'm looking at a tile and I'm trying to append all the op lists, I first look in which chunk I am, and I know that, for example, if I'm in this chunk, I only need to look at path number 2, and I don't need to run through all the path of my scene. Okay, so that's a little more efficient. And finally, if I can find the button on that pen. Okay, finally, we arrive to our latest step where Obsidian is buggy. And so we just restart it. And we zoom in. Okay, so now we have appended all our list, and then we do our raster, and that's where we go pixel parallel. So let's say I'm that center tile with that same op lists.
Yeah.
And so I have something like that, something like that. I know that I have +1 for that path, and I have something like that. Okay. And so let's look at that pixel here. So I go through the through the op lists. So here I'm crossing that element. So I'm going +1. That element I'm not crossing because it's on my left. And now I have an and, so I add +1. Is that right? Oh no, I know that this element also like goes from like crosses the right of the tile. So I have to add the shortcut that is here. So
yeah. So you assume that you're outside
yeah,
wrongly.
so I assume that I'm outside wrongly, so I add -1, and then I encounter the and that's where I add the bias.
Mm-hmm.
And so my winning number for that path is 1. And so I can shade that pixel with the correct color. And then in this case, I'm rendering front to back. So if the color is opaque, I just stop there. I don't have to check any of the other operations on the list.
Yeah.
And if my color is translucent, then I continue the list and I do essentially like the same thing.
Mm-hmm. Makes sense.
And yeah, that's the whole pipeline we have. Wow.
So you mentioned that this is. I have a couple of questions. So I guess first question is, how much of this that you just presented is from the original paper versus changes and optimizations that you made yourself as you were implementing it?
Yeah. So these things. There are a couple papers here. There is the so this categorization is from 2014 paper from Gassim et al. So there's that. The implicitization is from the Lublin paper from 2005. And this lattice clipping algorithm is the 2008 Nihab and Hope paper. But then basically the work in doing that efficiently is in like building the pipeline and making sure that that we're taking care, that we're taking advantage of the parallelism. So I also took inspiration for that pipeline. I took heavy inspiration from posts by Raf Livian, who's working on vector graphics animation backend called Velo, I think. But yeah, the basically like the theory is all in the papers. Some of them have implementation, like the Ganessim et al. Paper as CUDA implementation. But you still have a lot of work to do to make it work correctly on the GPU and be not so slow. And you also have like some tricks, for example, that I've not shown, where you can detect early if like a whole tile is covered. So you can just discard all the operations that follow and just replace the whole tile by one operation. So yeah, stuff like that in the pipeline are kind of my own my own brewing stuff.
Okay. The second question is, so you mentioned that these are techniques that were, some of them were presented in 2005, then 2008, then 2014. So not yesterday, but also not a long time ago. So what is the state of other vector engines. So, like, do you know if this set of techniques is used also in browsers or not, etc.?
So I've I've not seen that method used, like except by Ralph Levian. I don't think is if other backends are using them. Like a surprisingly big number of vector graphics backends are still software only.
So you mean CPU basically?
Yeah, CPU, not taking advantage of GPUs. You have also like other methods that are, for example, starting from the loop blend thing, you can branch toward other methods where you are using like the almost like the fixed pipeline, like at least like you are using the triangle rasterization feature of GPUs, and you're trying to do that stuff with triangles, like yeah, I don't know. Maybe I can just explain that because it's kind of interesting. So you have different ways of computing the winning numbers. If that thing stops being buggy. With the loop blend thing, you can say, okay, I have my path like here. Okay, and that's basically like a polygon in the interior with added Bezier curve to expand or carve that shape. And so if you take a point anywhere here and you just draw like a triangle fan to all these points, and you also add the triangles on the outer and inner parts, and basically you count the number of time a point is covered by a triangle. That also gives you like the winning number for that point.
Okay.
So you have like you have some rendering backends that use that triangle fan carving method. It works, and you can like take advantage of the stencil buffer to compute these winning numbers. So basically, you can do all that with rendering shaders instead of compute shaders. I mean, with fragment shaders instead of compute shaders. The problem with that is that it doesn't work so great when you have like a lot of overlapping shapes and translucent shapes and so on. So yeah, you have a lot of different methods that are used. I've not seen the Nehaben-Hope approach used much in the wild, but this is also something that's not always easy to know what it's used under the hood.
Yeah, I see. Did you benchmark your solution against, I don't know what other solutions people might otherwise want to use, like C libraries maybe? I don't know.
So I benchmarked my solution against my earlier solution. So the thing I was talking about, the triangle fan, that was one of my second attempts at doing vector graphics.
Okay.
And like my first attempt, like you can also like just triangulate, like linearize all your Bezier curves. So transform them into piecewise linear curves, like polylines, and triangulate the whole shape and just send the triangle soup to the GPU. So that the simplest stuff, but that means you have a lot of work on the CPU side. So that's what I did first. That was kind of slow. I did the triangle fan approach, which was better, but also kind of slow. And the best one I have is that last one. I have like on my machine, which is not like super beefy, I can render the ghost strip tighter in like 10 milliseconds or something, which is still kind of slow. And I think we're paying a lot of that to the fact that WebGPU doesn't have bindless textures and bindless attributes, so we are forced to do some like several passes. I also have a benchmark where I have like just like a big wall of text, and that's rendering a bit faster because it tiles better. Like since all the shapes are like just small letters, you have a better separation between tiles. And yeah, before all that, I was using Kero graphics. And it was like really, really slow. But it was like almost 10 years ago, I'd say. So it was all software rendered at the time. So that might have changed, and they might have a GPU backend now.
I see. What is the ratio between GPU versus CPU, roughly speaking, for something like the Tiger, for example?
For the Ghost Script Tiger, I don't have the. I don't remember the figures out the top of my head, but like the CPU is entirely negligible because like you're just sending the path directly to compute buffers.
Oh yeah, no, sorry, no, that's not what I meant. Sorry, what I meant is like comparing your solution implemented using GPU versus a solution that entirely uses the CPU.
Oh yeah, right. Yeah, again, I don't have the figures off the top of my head, but I already have like a kind of a 10 times 10 times improvement between like the first naive method I did myself and the last one. So I guess it's better than the software rendered version that I was using at the very beginning with Kero graphics.
Okay, cool. So this is the implementation in Orca for vector graphics, which is the baseline for everything, pretty much. Like
yeah, then the UI is built on top of that. So like all the UI boxes and controls are rendered using that graphics API. Something I didn't mention though is that you can also use GLES if you want to do 3D stuff in Orca. So I can show that very quickly. We have some samples here. So for example, we have like that fluid app thing, which is like GLES, like a fluid simulation. All done in GLES. That got faster. Okay, so we have that, and yeah, this one is like not super enlightening, just like a basic triangle. So you can do 3D stuff using GLES, and the goal is to replace GLES with WebGPU. Because the vector graphics renderer is currently implemented with WebGPU. And so we'd want to expose also WebGPU to user applications so they can use that directly. So you would have a layering with WebGPU at the bottom, then the vector graphics renderer, then the UI on top of that.
Understood. Okay, let's Man, this been a long episode compared to other
Yeah, I
episodes.
didn't keep track of time.
It's fine. So, do you have time for one last question? Like one
Yeah,
last bigger
sure.
topic? Okay, so I'm gonna put you back up as a big image. So we talked about the low level stuff. So we talked about the vector graphics implementation. We talked about the idea that Orca is about flipping the stack, meaning it's not a system where you have the DOM at the bottom and then you invent like a canvas on top of it and everything is technically a document, but also not really, kind of a mess. So there's also that. There's also the application distribution aspect, which is critical. I would argue it's one of the main things where you kind of can make a difference by coming up with a different approach compared to what normally desktop applications do. So I guess the last question is, if we kind of go more up high level, is so what is the license of the project? How do you plan to make it sustainable? Like, what is your medium to long-term goal when it comes to Orca?
Yeah. So regarding the license stuff, it's licensed like it's an open source project. It's licensed under either the MIT license or the Apache tool license. So yeah, you can go check out the GitHub repo. And regarding how to make it sustainable, so currently I'm just doing freelance work and in between contracts working on Orca, and well, for example, this past couple months I've been like working on Orca almost full time. At some point my money runs out and I need to get a job and do something else. So Orca relies on first my savings and then donations that really help. That's really helpful for the motivation. That really helps knowing that people support the project, and that helps setting time aside to really work on Orca and not worry about having other contracts and stuff to support myself. I'm also looking into grants. I've done some, like I've tried some with no success for the moment, but I'm hopeful that the project can, like, it has both like potential impact that is interesting, that might interest organizations that give grants to new technologies for the internet, for example. Or for organization that tries to promote software that is more respectful of users and stuff like that. And it also has a research aspect. So I'm also looking into research grants. But for now, yeah, it's only donation and my own savings.
I see. So no VC money?
No VC money. Fun story. I got contacted by a VC firm really early on, almost when we did the first blog post with the announcement of Orca. And I got like two VC firms like trying to contact me. Like one which seemed really sketchy, and which I just didn't answer to, and one which was like, okay. I had no intention of like taking VC money, but I was kind of curious because I don't really know that kind of world, and I was like, okay, like let's do a call, and I think that was really like an encounter of the third kind for them, because obviously they have the incentive of you selling out at some points. Yeah. That's their thing, and like one of the core goals of Orca is like to be a long-term thing that is open and that can't be rug pulled and that can be audited, and like, so it wouldn't make sense to sell out a thing like that. No users or no developers would want to develop apps for a new platform like that if they don't have any control of the platform, and no user would want to use it.
I'm not sure about the developers. I think some developers are kind of gullible enough to buy into platforms of that kind. But that's a story for another episode, I think.
But then I don't want to be like the grifter in the story.
Yes.
So it was like it was really nice. The woman from that VC firm was really cool, and we had a nice chat. But yeah, I had really no intention to sell up.
Your incentives were not aligned enough for anything to happen. That's interesting because I think on one end, obviously Orca has to prove itself. Like even though you don't want VC money, I'll steal some words, some expressions from the kind people, the VC money people, and it's like you even though you don't want VC money, you still have to prove that you can find product market fit, that you can have your growth, and like that the project does make sense. But what I find interesting is that there is no real system for projects that have proven that to become sustainable in a, let's say, standardized manner. So for example, you have the Linux Foundation, and there are projects in the Linux Foundation. So something like that kind of exists, but I've never seen really independent projects kind of get something from the Linux Foundation so that they can be sustainable, but also, kind of keep walking with their own legs. Maybe I'm missing something out, because if I have to be honest, I'm not like 100. I don't, there's a ton of things that I don't know about those realities. But I think it's interesting that, for example, I'm thinking about Zig. In the case of Zig, I don't think I wouldn't know if we wanted to, but I don't think there is a path for us, for example, to join the Linux Foundation. And that's kind of interesting. So, yeah.
Yeah, but in the case of Zig, like you kind of did manage to make your own organization, like to create your own kind of ecosystem where the project can be sustainable. And it's not like depending on like on another big organization like the Linux Foundation or something. So it kind of proves that it's possible.
Yeah, so. For sure. It is absolutely possible. It's not that easy, that's for sure. But and it's definitely possible. But still, I do find it interesting that the people that like basically the people that contact you are the VC people. It's not something else. What that something else should look like, I have no idea. Maybe it's an idea that doesn't make any sense. But like, it makes me think, like, what does exactly the Linux Foundation do, for example? And I don't want to to call out the Linux Foundation specifically because I don't know. But like, it's interesting that there are no other entities that are like more focused on open source in a sense.
I think it's really like a sign of the times. Like if you look at like ambitious projects around these kind of ideas about like the internet or interconnecting or like hypertext and things like that in the 70s and in the 60s. So like, first of all, like the public research effort was funded, but like the proportion has nothing to do with how the research is funded now. Like the money was flowing, and you just had institutions that were committed to fund this kind of projects, even if there weren't like provable return on investments. So if you take, for example, ARPA, it was an organism that was like actively like seeking projects to give them money, and that's something that has completely disappeared. And the type of institution that can provide you that kind of money are VC firms, but the incentives are really, really different from like from encouraging like research and expanding the thing you can do with computing. Like you have to have like a way out by selling and by having like relatively short-term return on investment. Like we are talking about like a few years, maybe 10 years. When you look at the 50s, like you had projects that were like not supposed to give any, like to yield any return on investment before like 20 years. So it's really like a different thing. And I think that in that kind of environment, we kind of have to create those spaces ourselves. And it has to be like a collective effort. And because these kind of institutions don't exist anymore, and the ones that do exist don't really align with what we want to do.
Yeah, that's a very good point. Well, Martin, thank you for sharing all your insight. This was amazing. I really enjoyed it from the very bottom to the very top of the abstraction ladder, or Hanoi Tower, however you want to look at it. So thank you very much. Is there anything else you want to say before we end the show?
Yeah, I don't know. You can go to the website. I don't know if you will put like the link.
People have linked it in chat already a couple of times.
There is we have a Discord server. The link of the Discord is also on the website.
Nice. You
can check out the GitHub repo. You can like, subscribe, donate if you're into that. I sure am. Yeah. I think. Yeah, that's it. Maybe if you want some book recommendations about like exactly what we were just talking, and we touched on that a little bit. There's like 2 books that you can read about the kind of the beginning of the internet and all the reflection about like hypertext and stuff like that. So there's this one, Dream Machine by Mitchell Waldrop. It's at Stripe Press. It's a biography of GCR Licklider, which was like in the 50s, 60s, and 70s. It was really at the nexus of like really interesting computer research. And he ended up at ARPA, funding the kind of project that Doug Engelbart and McCarthy and people like that did. So really like pioneering stuff about the internet. And like you can see all the things that could have been and that we don't have today somehow. And another one in the same vein is What the Dormouse Said by John Markoff, and it's more focused on the figure of Doug Engelbart and on the culture of the like around San Francisco in the 60s and 70s, and the personal computing revolution, and how it intermingled with the counterculture. So a really interesting book, and it tells of a time where the Silicon Valley was not only grifters and crackpots, so it's pretty interesting. And yeah, so if you want to continue like thinking about like interesting computer stuff, that are 2 good books to do that.
Awesome. Thank you for the recommendations. Well, everybody, this has been it. Martin, again, it's been a pleasure. And let's do another episode maybe in a while once you have some more new cool stuff added to Orca and a DARPA contract or something.
Yeah, for sure.
Well, then thank you, Martin, and everybody. I'll see you next time. Bye-bye.
Bye.
And outro.
This is how we